Okay, so in this video we're going to be graphing some absolute value functions. So just to start and to piggyback off of what we've been doing recently, we're going to look at the parent function f of x equals the absolute value of x. Okay, and some of us may recognize this as a v-shaped function, and if we don't, we can certainly figure out what it looks like just by picking some values for x and plugging them into the function. So for example, -2, -1, 0, 1, and 2. And whenever I'm not sure what a function looks like, I'm always picking -2 to +2 as my values that I plug in. So the absolute value of -2 is 2, absolute value of -1 is 1, 0, 1, and 2. Okay, and I'm just going to graph that parent function, and I have my point at 0, 0, 1, 1, 2, 2, -1, 1, -2, 2, and just with a little bit of thought, realize that the equation is going to continue in that way. So, and really, I only really need those 3 points in the center there. So for future reference, I'm only going to use 3 values because I know that it's V-shaped, and as long as I include this unique point here, which we call our vertex, which in this case is 0, 0. So as long as I include my vertex in my table and go 1 point to the left and 1 point to the right, I have a good idea of what that V is going to look like. Okay, so now we want to start graphing some children of f of x. So for example, g of x is equal to absolute value of x minus 3 plus 1. So we learned regarding our transformations, we learned that these additional numbers, the 3 and the 1, those are my c and my d. So this function is going to get translated right 3, which means I'm going to add 3 to my x's, and it's going to go up 1, so that means I'm going to add 1 to my y's. So really I can just take my parent function, and as I said before, I'm going to just pick those 3 numbers. So this is my parent, put a capital P there, and I want to graph my child function. So I'm going to take my x's and add 3, so that becomes 2, 3, and 4. I'm going to take my y's and add 1, so that becomes 2, 1, and 2. Now I'll go over here and graph my function, my child function. So 2, 2, 3, 1, and 4, 2, and I have my V-shaped graph. We can see that it's been translated 3 places to the right, and it has been translated up 1 place. And we can look and see that my new vertex is 3, 1. Now, as Alex stated in our 4th period class, he looked back at the equation and he noticed, Mr. Russo, are the c and the d always going to be your vertex? And that is absolutely true. So that's just a nice little check to look at the center of your table and to notice that the 3 is your c, the 1 is your d, and that should always be the vertex of your child graph. So let's go ahead and try another one. I'll try h of x is equal to -2 times the absolute value of x plus 1. Okay, I'm going to go back to my parent points, -1, 0, 1. That again is my parent. Okay, in this case, my a is -2, my c is -1. So in this case, I'm going to take my x's and I'm going to -1. I'm going to take my y's and I'm going to multiply them by -2. I'm multiplying because a is a multiplier. So -2, -1, 0, and then we have -2, 0, -2. So if I graph this function, my vertex is at -1, 0, and that makes sense because my c is -1. I do not have a d, so that is 0. So negative 1, 0, negative 2, negative 2, 0, negative 2. And I look at this child, and it is reflected over the x-axis, which is true because of the negative there. It is vertically stretched, so it looks a little taller, a little skinnier than my parent function because of this too. And I moved it one space to the left. Okay? And now, a follow-up question, since we're talking so much about domain and range with functions, the domain of this function is going to be all real numbers. And that is because the absolute value function continues out to the left and out to the right forever. It just keeps going out and out and out and out and out. So the domain is going to be all real numbers. The range, on the other hand, is going to be y is less than or equal to 0. And the reason it's going to be y is less than or equal to 0 is because it starts at 0 and goes everywhere below it. However, it does not go anywhere above 0. So my range is all of the values less than or equal to 0. So we'll try one more here. Let's say we have h of x equals negative 1/3 absolute value of x plus 2 minus 4. Okay, so my parent function again, it's the same parent function because this is an absolute value function, so I just keep referring back to that. My x's are going to be moved left 2. My y's, I'm going to take my y's and I'm going to multiply them by negative 1/3, and then I'm going to subtract 4 from them. Remember, like PEMDAS, we multiply, then add or subtract. So my x is negative 3, negative 2, negative 1. My y's negative 4 and 1/3, negative 4, negative 4 and 1/3. Okay, so then I'm going to go down here and I'm going to graph my function. So negative 2, negative 4, negative 3, negative 4 and 1/3, negative 1, negative 4 and 1/3. And I can see that this guy is getting shorter but much wider. You can also tell that he's been reflected, shifted to the left 2, and shifted down 4.